Welcome to Chapter 17, 7.3, Hourly, 17.3, Hourly Flow Rates for dosages per time infusions. Alright, so Rule 17.3 states, calculate the rate to administer a solution with medication using an electronic device in milliliters per hour, where you have D is your desired dose, Q is your dosage unit, H is the dose on hand, and A is the amount to administer, as usual. And those are the units that we will be using for each of those. You can use the proportion method, dimensional analysis, or formula method to find the hourly flow rate. So for the first example, find the hourly flow rate at which to administer IV morphine sulfate. Use the formula method. So we have ordered morphine sulfate at 4 milligrams per hour, and on hand we have morphine sulfate 10 milligrams per 100 milliliters, D5W. Alright, so we're asked to use the formula method, so what we're going to go ahead and do is first see if we need to convert any of the units. Well, we have the desired dose is 4 milligrams per hour, and we can have milligrams per hour, that's fine. And the dose on hand is milligrams, which we can have as well. So we don't need to convert any of the units. Alright, so all we're going to do now is go ahead and calculate. So we're going to use the formula. Amount to administer is D divided by H times Q, where in our problem here we have D is 4 milligrams per hour, H is 40 milligrams, and Q is 100 milliliters. Okay, we can go ahead and plug those in. So D 4 milligrams per hour divided by 10 milligrams times Q, which is going to be 100 milliliters. Alright, we can go ahead and cancel out some of the units. We can cancel out the milligrams. And then, calculating this out, we get 40 milliliters per hour equals A. Alright, so the amount to administer is going to be 40 milliliters per hour. Per hour. Alright, go ahead and box our answer. And let's go ahead and move on to the next example. So, for example 2, find the hourly rate at which to administer IV heparin. Use dimensional analysis. And we have ordered, that should be 1,000 units per hour of IV heparin using an infusion pump. On hand, 25,000 units heparin in 500 milliliters of D5W. Alright. Okay, so the first thing we want to do is look at all of our information and convert if we need to. So what do we have? Well, we know that the desired dose, D, is 1,000 units per hour. And the dosage unit, Q, is 500 milliliters, right there. And that was the dose. And let's see, the dose on hand, H, is 25,000 units. Okay, these are acceptable units, so we don't need to convert. They're both in the desired units. Alright, so the unit of measure that we're going to be using is milliliters per hour. So, amount to administer, a milliliters per hour. We don't need to have a conversion factor, so we can go ahead and just use our dosage unit, which is 500 milliliters, out of the 2,500 units. Okay, so our second factor, remember we're using dimensional analysis here, is going to be the desired dose, which is 1,000 units per hour, so times that by our conversion factor, 1,000 units in 1 hour. Okay, let's see if we can cancel any of the units. Well, units cancels. And we're left with a milliliters per hour is going to equal 500 milliliters. Oh, wait, take that back. 500 times 1,000 milliliters all over 25,000 hours. So AML per hour is going to go ahead and equal a really large number, 500,000 milliliters all over 25,000 hours, which we can simplify out to be 20 milliliters per hour. Okay, there we go. So the answer, the hourly rate, is going to be 20 milliliters per hour. The IV heparin will be administered at 20 milliliters per hour, period. Okay, so let's take a look at the next rule. But first off, please note potent medications may be ordered in amounts per minute. Amounts per minute need to be converted to milliliters per hour in order to program the infusion pump. So keeping that in mind. So to calculate an hourly flow rate from a per minute order, you're going to convert milligrams to minutes, to milligrams to hour, multiply the milligrams by minutes. For dimensional analysis, use 60 minutes to 1 hour as the first conversion factor. And then use proportion method or dimensional analysis to calculate the flow rate in milliliters per hour. Okay, so for example 3, find the hourly rate. What's been ordered is 5,000 milligrams esmolol, I'm not certain on that one, in 500 milliliters of D5W at 8 milligrams per minute via infusion pump. Okay, so the first thing, let's see what we have. Well, the dose on hand is 5,000 milligrams. The units that we're going to be using this in is 500 milliliters. And we need to convert our dose on hand. Well, we need to convert from milligrams per minute to milligrams per hour to be able to figure out our desired dose in the correct units. Okay, so there's 60 minutes an hour, so we can go ahead using right there what we are given. We have 8 milligrams in 1 minute. Times that by the 60 minutes in 1 hour conversion factor. The minutes will cancel, and we will be left with 8 times 60, so 480 milligrams per hour. Alright, so that right there is our dose. We had to convert to the right units for that. So 48 milligrams per hour. And now we can go ahead and calculate using the proportion method. So now let's calculate. And we'll use the proportion formula. So H is 5,000 milligrams all over our units are 500 milliliters. Dose on hand is 48 milligrams per hour, and A is what we are trying to find. So let's go ahead and cancel any of the units that we can. Well, we can cancel those units, and we can cross multiply. And we'll get A times 5,000 equals 48 over H times, and let me rewrite that actually. 48 over H, 1 hour, times 500 milliliters. And you can just put that over 1. Let's see. Well, we can go ahead and divide both sides by the 5,000 to solve for A. And we'll get is A equals 48 over H times 500 milliliters all over 5,000, which is a complex fraction. So if we rewrite this in the correct format, actually let's do 48. That's 48 times 500 milliliters per hour divided by the 5,000, which is going to end up being 48 times 500 milliliters all over H. And then we'll take the reciprocal, 1 over 5,000. Let's continue our work over here on the top. So what I did right here was I just converted it into the division so we can do the reciprocal instead of having to work with the normal complex fraction right there. So A equals 48 times 500 milliliters all over 5,000 hours. We can simplify that to be 48 milliliters per hour. And there we go. The amount to administer is 48 milliliters per hour. Okay, let's see. Oh, and that is it for this section.